Okay, gang, today we're going to be solving more difficult equations. I'm going to do the first four with you, explaining what we're doing in each step, what property we're using to complete the equation, and you're going to do the last four on your own. When you're doing them on your own, please make sure you're checking in with a partner to assure that you've got the same answers, and check in with me to make sure you've got the correct answer before going on to your homework and exit ticket. Okay, so for number one, we have a lot of things going on. We have parentheses, we have lots of different terms with x's and different values on each side. So there's two ways we could start this. We could start by distributing, or we could start by using the subtraction property of equality, distributing the 1/3, or subtracting 2x from both sides. It doesn't really matter which one you do first. I like to distribute first, so that's what I'm going to start with. So using the distributive property of equality, I'm distributing 1/3 to both sides. That gives us 9 divided by 3, which is 3x, minus 36 divided by 3, which is 12, plus 2x equals 8x plus 12. And I'm just going to write distributive here to show that that's how I got to this step. Then from here, I want to combine like terms on either side of the equation. So on the left side, I have a 3x and a 2x I can put together, which gives me 5x minus 12 equals 8x plus 12. And I combine like terms, which is the substitution property of equality. Now I want to combine like terms on opposite sides of the equation, starting with the x's. So I have a smaller coefficient of 5, which is smaller than the 8, so I'm going to subtract 5x from both sides. Make sure you bring down a negative or a minus sign that now acts as a negative. I get negative 12 equals 3x plus 12, and that was using the subtraction property of equality because I subtracted 5x from both sides. Now I'm going to get the constants together on both sides. So I'm going to take from the right side because that has two terms and bring one of the terms over to the left side. So if I subtract 12 from both sides, same signs, I find the sum. I get negative 24 equals 3x. And again, I use the subtraction property. And last, I divide by 3. So x equals negative 8. And that is the multiplication property, multiplication inverse property of equality. All right, so we get down to our final answer of negative 8 here, showing our work neatly so that the process is clear as we're going on. All right, let's take a look at another example. Number 2. Same kind of setup here. We have the distributive property, we have multiple variables of x on different sides and constants on both sides. So again, I'm going to show you another way to set this up. So on the last one, I distributed first. This one, I'm going to add 5x first. That's the addition property of equality. So I'm left with 1/4 of 12x plus 48 equals 2 minus 1x now, or just x, because positive 5 minus 4 is positive 1, not negative 1, so it should be plus x. And that is the addition property of equality that I used there. From here, now I'm going to use the distributive property to get rid of the parentheses. 1/4 of 12 is like 12 divided by 4, so it's 3x. A fourth of 48 is 48 divided by 4, so that's 12, equals 2 plus x. And that's the distributive property again. Uh-oh. Sometimes you hit the eraser and everything disappears on you. All right, so that was 3x plus 12 equals 2 plus x. All right, and that was the distributive property. I'm sorry, that disappeared. I'll just let that be. So now I want to combine x's on both sides. It makes more sense to subtract x from 3x than subtract 3x from x. So I'm going to go this way, and I'm left with 2x plus 12 equals 2. Last, That was the subtraction property there. Next, I'm going to subtract 12 from both sides, take from the side with two terms, and make it so that there's only one term on each side. I get 2x equals 2 minus 12, which is negative 10. And last, I'm going to divide by 2, and I get x equals negative 5. Okay, so again, I use the subtraction property here and the multiplicative inverse property here. Again, it's very important that you work neatly. Make sure you're carrying down any minus signs as negatives so that you don't mess up your signs in the end and get an incorrect answer. All right, let's take a look at the next example. Okay, number 3. Now I have parentheses on both sides, a little bit more going on. So I'm going to start first with the distributive property, distributing the 5 halves and the negative 3/4. You have to make sure you're holding on to that sign. So when I'm multiplying by 5 halves, it's kind of like multiplying 5 halves by 3 over 1. So I get 5 times 3 is 15, and 2 times 1 is 2. So it's 15 halves x minus 20 divided by 2 is 10 times 5 is 50 plus 11 equals 48 minus, I can think of this as 2 over 1. 3 times 2 is 6. 4 times 1 is 4. So it's 6/4 x. Then a negative times a negative is a positive. And then 16 divided by 4 is 4 times 3 is 12. All right, so I've simplified it quite a bit. Now on both sides, I can combine some constants. So I'm going to bring down this 15 halves x. And negative 50 plus 11 is like doing 50 minus 11 with a subtraction sign or a minus because the 50 is further negative. So 50 minus 11 is going to give us 39 equals. Then on the other side, I can put together the 48 and the positive 12, which gives us 60 minus 6/4 x. All right, now right away, maybe you notice, well, 6/4 can be simplified. Let's change that. If I divide both 6 and 4 by 2, I get 3 halves instead. And that will make this easier to combine. So now I can put my x's together. It makes more sense to add 3 halves to 15 halves than to subtract 15 halves from negative 3 halves. So I'm going to add 3 halves x to both sides. Cancels. I'm left with 18 halves. Well, 18 halves is easy to simplify. That's 9. So I'm going to change that right away to 9x minus 39 equals 60. Then I'm going to add 39 to both sides. I get 9x equals 99. Then I'm going to divide by 9, and x equals 11. Okay, so we used the distributive property. We used the substitution property of equality by putting together the constants. We use the addition property of equality, again the addition property of equality, and last the multiplication inverse property of equality. All right, I'm going to do one last example with you before you're on your own. Number 4, similar setup, only parentheses on one side here. So we're going to start by distributing the negative 5 halves using multiplication, multiplying by the numerator, dividing by the denominator in any order. So I bring down my 5. Common mistake is kids forget about that first number if there is one there. So we get negative 5 halves x, since that x is just 1, plus 8 divided by 2 is 4 times 5 is 20, plus, because I'm multiplying a negative by a negative, bring down my equal sign. I can combine 28 and negative 36 right away here. So if you think of 36 minus 28, that would be 8. So 28 minus 36 would be negative 8. And the 1/4 x can come down. So it's 1/4 x minus 8, or negative 8 plus 1/4 x. So here in that step, I use the distributive property and the substitution property of equality. Now I'm going to use the substitution property of equality again to combine this 5 and the positive 20. So I get 25 minus 5 halves x equals 1/4 x minus 8. Now I want to get my coefficients of x together. Makes more sense to add 5 halves to 1/4 than to subtract 1/4 from negative 5 halves. So I'm going to add that, get rid of the negative, bring down my 25 and my equal sign. Now, 5 halves and 1/4 have different denominators, so I'm going to change 5 halves to 10/4, doubling both the numerator and the denominator. Gives me 11/4 x minus 8. Now I add 8 to both sides. I get 11/4 x equals 33. And last, using the multiplication inverse property, I multiply by 4 elevenths, cancels these out, multiply by 4 elevenths. And this actually winds up being very nice because 11 goes into 33 evenly. 33 divided by 11 is 3, and 3 times 4 is 12. So our final answer is x equals 12. So again, it's going to get challenging. You have to work through it slowly. Keep in mind that if you don't always get the right answer, it's just because you made one little mistake. That wouldn't mean you would get the whole thing wrong. As long as you're showing that you understand how to work through solving an equation, you would get most of the credit on a test or a Regents exam. All right, so you're on your own. Help your groups out. Raise your hand if you're having problems. Check in with me for each answer to make sure it's correct.